Hello, today's lesson is on variables, constants, expressions, and equations. We're going to introduce the concepts today. There's going to be a lot of vocabulary, so pay attention. I will make the notes available. It's very important that you understand that we're moving away from arithmetic. We're moving into algebra, and I'm very happy about that. Algebra is a far more interesting subject than arithmetic. Yeah, it's adding, subtracting, multiplying, and dividing, but now we're introducing variables. And variables make all the difference in the world. They are far more interesting to work with because they apply to much more general things. Okay, let's begin. First, what do you know about these words? Now, I know it says discuss with your partner, and with this being remote learning, you're not discussing with your partner. But think about them. What do you know about the word constant, variable, expression, evaluate, substitution, equation, and coefficient? Think about what you know about these words. We've used some of these words in class already, but not all of them. Think about it. Okay, so let's move on. Constants. This is the definition of constant. They have a fixed value. It never changes. It's constant. That's why it's called a constant. Here are some examples. 8 is a constant. How much is 8 worth? 8 is worth 8. It is always worth 8. It never changes. -4 is a constant. How much is it worth? It's worth -4. It's 4 below 0. It is an integer. It does not change its value. 3/4 is a constant. It's worth 75 cents is 3/4. 0.75, 3/4. It's always the same value. It does not change its value. Pi is a constant. It's between 3.14 and 3.15. Its value, it's written as a decimal, never ends, but it has one specific value. It is a constant. All right, so that's what a constant is. It has a fixed value. Give me a symbol. I know what its value is. It's always that value. It never changes. All right, next one. A variable. A variable has no fixed value. It changes from expression to expression. It varies. Here are some examples. X is a variable. X could equal 5. But in another situation, x could equal 6. These are the ideas. T is often used as a variable. M is a variable. This is the Greek letter alpha. Alpha can be used as a variable. K is often a variable. K is a very important variable. It's used in a lot of situations. These are what we call variables, and they are called variables because from expression to expression, the value of the variable changes. It's usually fixed within one expression. So if I say 2x plus 3x, then this x has the same value as this x. But then in a separate place, if I say 6x, this x could be different. So that's how it varies. It doesn't vary within an expression. It varies from expression to expression. Okay? Now, next. So I've been using this word expression. What is an expression? It's a collection of variables, constants, and or operating symbols that has a value. 3x is an expression. 8 plus 4 is an expression. 13 is an expression. M minus 2 is an expression. Notice it has a variable, it has a constant, it has an operator symbol. It doesn't have to have an operator symbol or even a variable. Here's 13 is an expression. Its value is 13. It is an expression. It's also a constant, but it doesn't have to have anything else. 8 plus 4 is an expression. It has two different constants and it has an operator symbol. Its value is 12, but the expression is 8 plus 4. 3x is an expression. This means 3 times x because there's nothing between the 3 and the x, and you know nothing means multiply. So it is a variable and a constant There is no operator symbol, but there is an operation in it. It's multiplication. That's what an expression is. Next. Now, there are different types of expressions. One type is called a constant expression, and a constant expression contains only constants and has no variables. And since it has no variables, that means that we know the value. All expressions have value, but we don't always know the value. In this case, we know what the value is. So 3 times -7, the value is -21. This is a constant expression. 12, the value is 12. It is a constant expression. 8 minus 2 3/4, the value is 15 1/4. We know its value. This is a constant expression. These are the expressions. These are the values of those expressions. Easy enough. Constant expression. It only has constants. So if there are constant expressions, there must be variable expressions. And there are, in fact. So it may have constants. It doesn't have to. But it will contain variables. It does contain variables. It doesn't have to have. So now, because they contain a variable, the value is not known. J. We don't know the value of J. It could be anything. If we did know the value of J, we could figure out what the value of J is. This expression is, but we don't. 3i. We don't know the value of I, so we don't know what the value of that expression is. It could be anything. It depends upon what the value of I is. 2k plus 4. We know what 2 is worth. We know what 4 is worth. But since we don't know what k is, we do not know the value of that expression. We know it has a value. We just don't know what it is because it has a variable. And since we don't know the value of these expressions, and in fact the value could change, these are called variable expressions. All right. Equations. An equation is when we have two expressions set equal to each other. They might be true, they might be untrue, or they could be open, which means we don't know if they're true or not. So, here's an example. 8 plus 4 is an expression. 12 is an expression. The equal sign between them says those two things are equal. Are they? Is this true? Yes. Because 8 plus 4 is 12 and 12 equals 12. This is a true equation. 1/2 is an expression. 0.5 is an expression. We're going to put the equal sign between them, therefore making this an equation. Is it a true equation? Yes, 1/2 is equal to 0.5. This is also true. 3x equals 36. 3x is an expression. 36 is an expression. We put an equal sign between them, making that into an equation. Is it true? We don't know. It could be true. If x is equal to 12, it's true. If x is equal to 5, it's not true. We do not know whether or not this equation is true. That is why we call this an open equation. It might be true, it might not be. It depends upon the value of the variable. So, coefficients. Coefficient is the number that multiplies the variable. So, here's an expression, 3x. Here's an expression, 24a. Here's an expression, 2/3 m. Here's an expression, -3h. You find the coefficients. I'll give you a moment. Pause if you need more time. Let's see if you're right. So 3x, the coefficient is 3. 24a, the coefficient is 24. 2/3 m, the coefficient is 2/3. -3h, the coefficient is -3. These are the coefficients because these multiply the variable. That's the definition of a coefficient. Now, one of the key skills of working with these variables and and equations and expressions is evaluating the expressions. And evaluating means find the value of the expression. Sometimes it's easy. So evaluate this expression. 4 plus 2 parentheses 8 minus 3. Take your time. Figure it out. Did you get 30? Oh, good. I'm glad you didn't get 30 because 30 is wrong. You do 8 minus 3 first, and that is equal to 5. So this is 4 plus 2 times 5. 2 times 5 is 10, so you do 4 plus 10, and altogether that's worth 14. And that means we evaluate the expression. So that's easy to just do some arithmetic. Maybe you got it wrong, but you're getting better at it, so it's easy eventually. And sometimes, though, it is impossible. So evaluate this expression. 4j plus 9. Go ahead, go ahead. No, you can't. It is impossible to evaluate that because you do not know the value of j. J is a variable. And until you know the value of j, you cannot evaluate it. It is impossible. All right, that is a variable expression. You cannot find its value. All right, next. So, evaluating open expressions. So you can evaluate them if they have a variable expression, as long as you know the value of the variable. So if we can evaluate the expression 4j plus 9 for when j equals -2, your first step is to substitute the value for the variable. This is called the substitution step, and it is absolutely vital. J is the variable. J equals -2. So we take the -2 and we replace j with -2. And we get 4 times -2 plus 9. Now, the parentheses there, they don't mean anything. It's just to separate it. We know it's 4 times j, so we have to write it in a way that says 4 times -2. So then we just evaluate it as a number, a constant expression. So remember using order of operations. 4 times -2 is -8. -8 plus 9 is 1. The value of this expression, 4j plus 9, equals 1 only when j equals -2. Now, try the same expression, 4j plus 9, for j equals 5 this time. See what you get. I'll give you a few minutes. Make sure you have your substitution step done properly. What'd you get? Well, here you go. Let's substitute in. So first I'm going to take out the j, leave the 4, and I'm going to put 5 in. So I'll put in a 5 there. Take out the j, put in a 5. That's the substitution step. 4 times 5 is 20. 20 plus 9 is 29. Did you get 29? I hope that you did. All right, so now I want you to practice evaluating variable expressions. Complete this table for p equals -8. So in this space, you're going to write the substitution step. P equals -8, p is equal, and 5p plus 8. Write your substitution step here, and write the value here. Write your substitution step here, and the value here. Substitution step here, and the value here. Substitution step here, value here. Here are the expressions that you're going to use. Okay, in every case, p is equal to -8. We're not changing the value of the variable this time. It's going to stay the same for all of them. All right, give you a few minutes. Pause the video if you need more time. Okay, here I am. I'm going to show you how to do it. So, I'm going to change colors. So in p is equal to -8. 5p plus 8 means 5 times negative 8 plus 8. 20 minus 3p is 20 minus 3 times negative 8. Opposite of p plus 8 would be the opposite of negative 8 plus 10. 12 minus p is 12 minus negative 8. See how I substituted in each case? P for negative 8, P for negative 8, P for negative 8, P for negative 8. Make sense? So now let's find the value. Okay. Find the values. 5 times negative 8 is negative 40. Negative 40 plus 8 is negative 32. 20, negative 3 times negative 8 is positive 24. 20 and 24 makes 44. Opposite of negative 8 is 8. 8 plus 10 is 18. 12 minus negative 8 is 20. Did you get those values? Here it is typed out for you. Compare what you did on your work with what this is. Do you have any questions so far? All right. Next. So check your understanding. Do you know what a constant is? Do you know what a variable is? Do you know what an expression is? Can you evaluate an expression, whether it's a constant expression or an open expression? Can you show me substitution? Do you know what an equation is? Do you know what a coefficient is? Check your understanding. Everyone good? All right. So, do you understand how to evaluate a constant expression and evaluate a variable expression if I give you the value of the variable? These are two skills that you need to know. Good job. You should now be ready to embark on your algebraic adventures.